Different people, different instruments have their own unique sound. We call this timbre. My name is Jorge, I'm a physicist, and we're going to talk about the science behind timbre. A human voice, an instrument, produces a sound that is comprised of many frequencies, not just one. Something like a tuning fork can produce one frequency, and that is why it has a unique sound. And that is why when you whistle, you start to sound more similar to other people, because now you're honing in on just a frequency or a small set of frequencies. But in general, the timbre of a sound comes from how those frequencies are spread out. And every instrument, because of its shape, of its mode of vibrations, will produce a slightly different sounding note. We quantify this using a power spectrum, which basically lays out all the frequencies present in that signal, and then the amplitude of each frequency. So for signals that have a lower frequency, you'll see amplitudes peaked more near the low end of the spectrum, as in this plot. Some signals can have a lot of dominant frequencies, like the one below me. You see a spike there. These dominant spikes are responsible for what we call pitch, the particular note that we hear. Taking any signal and decomposing it into the power spectrum is a powerful method to not only analyze it, but potentially compress it. Because if a signal is comprised of many dominant peaks, like that one below, you can recreate a signal or a sound using only those dominant frequencies and leaving out the rest, and you will get something that sounds similar to your original signal, but it won't be perfect. I want you to hear this talking piano as an example. So that's a little creepy, and what you're hearing is an artifact of compression. Basically, the piano only has 88 keys, 88 distinct frequencies, but the human voice produces countless, continuous, you could say millions of them. So the piano is just dropping a lot of the ones in between the keys. And when you try to recreate the human voice with that piano, you get this uncanny, spooky thing. It's really an artifact of trying to represent a signal that has almost a continuous frequency response with a discrete frequency response. Different instruments sound different because they have different power spectrums. They produce, for a given note, a different set of frequencies. Though the dominant frequencies will be at that note you're playing, there's going to be a lot of other ones, and this is the timbre. It's all of those different frequencies that are present in the sound. It is why you and I sound different. It is why a piano sounds different than a trumpet. If you want more videos about the science behind music, let me know. Thank you for your time. Go Power Spectrum.